Hi to all. In this video, we will cover a couple of questions such as what is the variance, what is standard deviation, correlation, and beta. And we will solve all of these questions at once using the same data set, which is just comprised of 5 observations of Pepsi, quote unquote, and S&P 500, quote unquote. So let's begin. When we work with the variance of an asset, there is another video where you can see a little bit more in detail how the variance is calculated, but let's follow step by step its calculation here. So we have two approaches. Let's take the long approach and then we will use Excel command to calculate this much faster. If you're following the long approach, the first thing is to get the average return. So step one, get the average return, and you will do this for both Pepsi and S&P 500 because we will calculate the variance for each one of them. So average return is simply average, right? And if you look at the previous material, we will understand why the expected return can be calculated using this simple arithmetic average when we are working with historical data. Now, the second step is to calculate the deviations from the mean. And let me, instead of working with average return, let me call this expected return or mean return. I will use the word mean because then we can use deviations from the mean, right? So what we will do is we will calculate the deviations from the mean for each one of these 5 periods. So Pepsi in period one, the deviation is, well, the return is a 5%, and the mean return was actually 4.2. So we had a return that was 0.8% above the mean return, right? Now the let's lock this last cell so we can scroll it to the right and it will still make reference to that cell where the mean return is H5, right? So we will scroll this to the right now, and now we have all the deviations. If I look at the last of the cells, please notice that because we locked H5, now the cells that we're making reference to the returns here, B, C, D, E, F, those are changing, but the cell that where we have the mean return, that one is not changing. That the reference is always H5. Now let's do the same thing for S&P 500. So we will have this, and then we can scroll again to the right, and now we have the deviations from the mean, right? So how far above, how much the return we actually obtained, and in reality, the realized return, if it's above or below the mean. Now let's take a third step, which is square the deviations. Okay, so for more details, you should look at the content where I'm covering the variance of the returns and the standard deviation, so you can see this in more detail and perhaps more visually as well. But for now, we're just following the steps to solve this in the long approach and the short approach. So when we are calculating variance, right, now we need to get the square of the deviations. Now let's do it. So this is a very simple step because we just need to square the deviations here. And then we can move this to the right, and we do the same with the deviations of S&P 500. And now we have all the deviation squares. Now, the last step that we will follow is simply the average of these squared deviations, or in other words, we should add them and divide them by the number of observations by 5. But let's call this step average of squared deviations. And that will be equal to the variance. So when we do average of these squared deviations, now what we're getting here is the variance. This is the variance of Pepsi, and this is the variance of S&P 500. Now just to illustrate this, let's use confirm I'll say confirm with Excel. Now you can directly jump uh, and use the Excel command, which allows you to calculate the variance of a distribution of returns. So this is var.p. So rather than taking all of these steps, you can directly use this command. It is good that we have followed all of these steps because now you know exactly what Excel is doing, but you can simply just select the returns and you will see that these numbers are the same, right? So we have the same number here as we have here. Now let's do the same with S&P 500 and we will confirm if we select all the returns that the number we get as the variance is exactly the same as what we get when we use the Excel command. Okay, now what is the standard deviation? And for the standard deviation, I'm going to go down here, and then for the standard deviation, and I will just do this. Okay, let's go right here where we have, as a matter of fact, let me move this a little bit to the right. And then standard deviation, right, is just the square root of the variance, right? So we just need to get the square root of the variance. I'm going to, yeah, this is right, Pepsi and S&P 500. Remember, these are not actual returns, but these are random returns. We're just using Pepsi and S&P 500 to illustrate this better. And now the same thing, square root of S&P 500. Now the interesting thing about standard deviation is that we can get it to a percentage. We can, and it is comparable to the actual expected return, right? And there are some properties. If you look at one standard deviation to the right of the mean, two standard deviations, three standard deviations, then you have some. You can basically calculate um, the maximum or minimum or uh, the highest return you should expect given or assuming that the distribution is normal. Okay, so now we have this. This is the standard deviation. Now we just took this long step again and we got the square root of the variance, right? So if we were asked about the standard deviation, we would just take the long approach and then get the square root of the variance. But we can also use this S10 STDEV dot P, and then we can select these returns of Pepsi, and then we can do the same STDEV the P, and we can select the returns of S&P 500, and we will confirm very quickly that the Excel command just gets the same numbers we got through the long approach very quickly. So we don't need to take the long approach, but now we know what Excel is doing when we use this stdev command, right? So that's the command for the standard deviation. So now we have already resolved this question and this question for each one of the assets, but what is the correlation between the two? Well, in step 3, we will do something different, correlation between Pepsi and S&P 500. And rather than squaring the deviations, right, I'm going to copy this. Okay, and then I'm going to move this actually a little bit lower, a little bit down, and I'm going to call this 3A, and I'm going to call this one 4A, and this one 5A. And now let's name this one 3B, which is, okay, if we want to calculate the correlation between Pepsi and the market, the first step is the same. You need to get the mean return. The second step is the same. You need to get deviations from the mean for each one of the periods in both cases of Pepsi and also in the case of S&P 500. Okay, now we're almost done. We go to correlation. And in the case of correlation, step 3 is different. So in step 3, rather than, and I'll just make this division here very clearly here. So now in this step, rather than squaring the deviations, what we will do is we will multiply the deviation of Pepsi in period 1 by the deviation of S&P 500 in period 1. So we will multiply the two deviations, the the interaction of these two deviations, and we will do so in each one of the time periods. There we go. We can just scroll to the right. If we look at the last one, right, we will see that we are just multiplying the deviations of Pepsi and S&P 500 in period T5 or year 5, month 5, whichever is the frequency of your data. Let me remove this percentage and just change this to decimals because this interaction of the deviations, it's uh, not easily under uh, it's not easy to understand it just by looking at it as a percentage, right? So now let's take step 4b, and in 4b now what we will do is the same average, but now we will not average the square deviations, we will average the interaction of deviations. Okay, so what we will do is just average of these 5. Okay, and there we go. There we go. We have this average. Now, we do not have a correlation for each one because let's keep in mind that this correlation, if we try to get the correlation of S&P and Pepsi, it's exactly the same as the correlation of Pepsi and S&P. So we just have one measure of correlation between the two. Now, when we get the average of the interaction of the deviations, now we have something that is called covariance, right? Okay, and the last step, we have one more step, which is not just confirming with Excel, which is we need to divide by the standard deviation of asset 1 and by the standard deviation of asset 2. Okay, so step 5b will be divide covariance by, and then I'll open a parenthesis, standard deviation of Pepsi multiply by standard deviation of S&P 500. And there we go. So what we have to do is just divide this covariance that we got here, and we will divide it by the multiplication of the standard deviation, which we already have here of each one of the assets. And then what we are basically doing is just to some extent we can intuitively think about this as we are normalizing this covariance, right? And so what will happen is that we will end up with this measure that can only take a value in a range between -1 and +1. Okay, and we have this 0.81. A correlation, if you get any number below -1 or above +1, that's not right. And then intuitively, correlation, if correlation is 1, and usually we use the letter rho to represent correlation, but let's refer to it as correlation. If correlation is 1, then the two assets are perfectly um, correlated linearly. There's a perfect linear relationship between the two, which means if one asset increases by 1%, if one asset has a return of 1%, the other asset will have a return of 1% too. And if correlation is -1, so these are the two possible extremes, then the two assets are perfectly negatively correlated. And if, let's assume, one asset has a 1% return, then the other asset will probably have a 1% loss. Okay, and then it is easy to intuitively use our intuition to understand what happens with any value in between. For example, here we're getting a correlation of 0.81. That just implies that these two, Pepsi and the stock and S&P 500, the market, are highly correlated and are almost perfectly correlated, perfectly positively correlated. However, let's keep in mind that this data is random, so these are not actual returns from Pepsi, and these are not actual returns from S&P 500. Now we calculated this. Let's take one final step, which is confirm with Excel. You can use this Excel command, which is Corel, and Corel should do exactly the same that we have done in this long process. So we just select all the returns of Pepsi, comma, all the returns of S&P 500, and then we type enter, and you will see that this is 0.81402. And if we add more decimals, more nor less, not less, then we see that the number matches exactly what we had calculated through this long approach. Now let me just add this are perfectly positively correlated. And then so now we know how to get the correlation. Now we have one last thing, which is the uh, beta. Now the beta, and this is the good thing, I'll just put it in bold. I'll format this in bold because it's going to be quite simple. Now the beta, the way we calculate beta is just the covariance between two assets divided between the Pepsi and the market, between an asset and the market, and then we divide by the variance of the market, right? So the way we can do this is beta, and now I'll write this quick formula here: covariance of stock and the market divided by the variance of the market. So I'm missing a parenthesis here. And now let's just do that calculation because we have everything we need for this calculation. We have the covariance here, and then we are dividing, or we should divide by the variance of the market. And pay attention to this. Many times I see projects or I see some student that make a mistake because they divide by the variance of the stock. We are dividing by the variance of the market in the case when we are trying to get when we are getting beta, right? And now we have this beta. This is the beta of Pepsi, and that's it. When we talk about a stock beta, we already know it's already implied that we are talking about the beta with respect to the market. Now, one quick way of getting beta using Excel is using this command, which is slope, because the beta is basically this can be considered this slope when we regress the returns of Pepsi on the returns of the market. So then known Y's, okay, so the known Y's, we're going to look at this returns of Pepsi, and then we're going to use this known X's, and that's where we're going to select the returns of S&P 500, and we can quickly see that we are getting exactly the same number that we had gotten before through this long approach. So you can also use this short formula from Excel. Confirm with Excel. One last thing we can confirm with Excel we did not do is this number, which is the covariance, right? So we have confirmed with Excel everything we have calculated except the covariance. We can also confirm the covariance using Excel. So let me long approach and then confirm with Excel. And Excel has this formula which is covariance.p. Now, by the way, we are always choosing .p. That means population. That means we're assuming we have all the population data. That is, we are for simplicity doing that. Usually we must acknowledge that we are working with a sample. If we are using a sample of returns, so we are not using the population of all possible returns, or if you're looking at the statistics of a sample of a group and you're not looking at all of the individuals of a group, then you use covariance.s. that will make a slight modification to the denominator just to account for this, just to make this small adjustment, uh, just to keep in, just to correct the measure, acknowledging that you're working with a with less than the complete population. It was a little bit confusing, but it's basically changing from n to n minus 1, the denominator. That's in long story short, right? But covariance dot p, let me go back to this. Covariance dot p, we can confirm this just by using this covariance. And then we select this, comma, and then we select the returns from S&P 500. And then we close this parenthesis here, and then we see that the long approach we had taken before, we are also getting the same number when we're using the command from Excel. Okay, so now you know the long approach and you know how to get these calculations of beta, correlation, standard deviation, and variance using the Excel commands. But most importantly, you know exactly what Excel is doing when you are using these commands. Okay, I hope this is helpful. I would suggest just use the Excel command, learn them, and because these are important shortcuts, they can save a lot of time. But do not forget to also acquaint with the long approach calculations so you know what these short commands provided by Excel, what they are actually doing. Okay, so I hope this is helpful. Thank you for your attention.